All right. First thing is that we're going to say that the cosecant of x is equal to 1 over sine of x. The secant of x is equal to 1 over cosine of x. The tangent of x is equal to 1 over the cotangent of x. And the tangent of x is also equal to sine of x over cosine of x. The sine of x is equal to 1 over the cosecant of x. The cosine of x is equal to 1 over secant of x. The cotangent of x is equal to 1 over tangent of x. And the cotangent of x is equal to cosine of x over sine of x. I bet Macy's mad right now because I'm going 7 million miles an hour. So, those are the 8 basic identities. Then you're going to make a little section called the Pythagorean identities. We have 3 Pythagorean identities. Sine squared of x plus cosine squared of x equals 1. Secant squared of x equals tangent squared of x plus 1. And cosecant squared of x equals cotangent squared of x plus 1. And then we have a section called the odd and even identities. The odd ones are the sine of negative x is equal to negative sine of x. The cosecant of negative x is equal to negative cosecant of x. the tangent of negative x is equal to negative tangent of x, and the cotangent of negative x is equal to negative cotangent of x. And then we have two even identities. The cosine of negative x is the same as the cosine of x, and the secant of negative x is the same as the secant of x. All right. So that's the end of writing on the note card for today. So what we're going to do is we're going to do a little bit of practicing with this. So if I would have an equation such as the sine of x times the cotangent of x times the secant of x plus 1, and that's all divided by the secant of x, what would that whole thing work its way down to? Well, for those who missed that Friday, where a bunch of people were missing, what you want to do is you want to work this way down so it's just sines and cosines without any cotangent, secants, or cosecants or that in there. So we'd leave it as the sine of x, and then cotangent is equal to what? Well, don't say 1 over tangent in this case, because we're trying to get in terms of sines and cosines. So what's cotangent equal to? Cosine of x over sine of x. What's secant equal to? 1 over cosine of x. And what's secant equal to? 1 over cosine of x. So what happens here is sine and sine cancel, cosine and cosine cancel, so I get 2 over 1 over cosine of x. Well, I have a complex fraction. I can't leave things as a complex fraction. So how do I get rid of the complex fraction? multiplied by the denominator of the denominator. These cancel, so it's 2 cosine of x, and I'm done. Okay, so you have some problems like that. Then you'll have some problems like this. Tangent of x in terms of secant of x. Okay, I want to solve for tangent of x, and I want to put it in terms of secant of x. Okay, so I want to get tangent of x alone on the left side of the equation. Now, is there anything that involves both tangent and secant in the same equation? Well, if you look at your Pythagorean identities, there sure is. I know that tangent squared of x plus 1 equals secant squared of x. Now, you might say, well, on your sheet, you said secant squared of x equals tangent squared of x plus 1. Well, what I'm solving for, I want to have on my left side. I want to get tangent alone. How do I get tangent alone? Subtract 1 from each side. Tangent squared of x equals secant squared of x minus 1. How do I get tangent alone? Because it's not alone yet. I have tangent squared, so I have to take the square root of each side. I take the square root of the entire side. It's not the square root of secant squared minus 1 is just secant minus 1. It is the square root of secant squared of x minus 1. You leave it under the square root. Now it's either a positive or a negative, depending on what quadrant that we're in. Okay, so we leave it like that. Okay, so that is pretty easy. What's not so easy is if you have cotangent of x in terms of sine of x. Now, cotangent of x, we know, is cosine over sine. But that's not just in terms of sine and sine only. It's cosine over sine. So we can't do it that way. So is there a Pythagorean identity involving cosine and something associated with sine? Well, the Pythagorean identity with cotangent is what? Cotangent squared of x plus 1 equals cosecant squared. And can I put cosecant squared in terms of sine? Yes. So the way we do this one, and this one's a little more complicated, is cotangent squared of x plus 1 equals cosecant squared of x. So then what do? Is I'll get cotangent squared alone in a little bit. But I'll leave it like this for one step. Cosecant squared is 1 over sine squared of x. So cotangent squared of x, if I want it alone, what do we do with this 1? Subtract 1. Now, when I take the square root, because I'm going to eventually take the square root of both sides, right? When I take the square root, I don't want to have two different things, one with a fraction, one without a fraction that I'm taking the square root of. So this 1 is going to become a common denominator. So 1 is sine squared over sine squared. So cotangent squared of x equals 1 minus sine squared of x over sine squared of x. Okay, see how that works? Now, I have cotangent in terms of sine, but it's cotangent squared and sine squared. So at this step, I'll take the square root of both sides. Square root of cotangent squared is cotangent of x. The square root of the top is just the square root of top, 1 minus sine squared of x. But the square root of sine squared is just sine of x. And this is how we would leave it. So, the first of the 2 assignments today, you'll be doing a little bit of this solving. You'll have a couple problems over that, and then 4 problems over this. Okay, and we'll go over them later this class period. So on page number 165, you have 15 through 20, all of them. So that's 6 problems to do in the next half hour. And then we'll have a short, I'll talk again a little bit, and then we'll have an assignment for you to do outside of the classroom.
You said 15 through 20.
Yep. Page 165, 15 through 20 all. You got about a half hour. Let's crank these out.